Imagine a galaxy filled with billions of stars, planets, and cosmic dust, all slowly suffocating. The cause? A supermassive black hole at its core, devouring everything in its path, leaving nothing behind to form new stars. Recent data from the James Webb Space Telescope has revealed groundbreaking evidence about how these black holes not only feed, but also starve their galaxies to death. Stay tuned to learn how this cosmic predator seals the fate of entire galaxies. Let's start by understanding what supermassive black holes are. These are gigantic, densely packed objects located at the centers of most galaxies, including our own Milky Way. They are millions to billions of times more massive than our Sun. Supermassive black holes have an enormous gravitational pull, capable of consuming everything that comes near gas, stars, planets, and even light. But while they are famously known for their immense appetites, these cosmic monsters can also have a far more sinister role, killing the very galaxies they reside in. The latest revelations from the James Webb Space Telescope show us how they can starve galaxies of the material needed for star formation, pushing them into a state of cosmic death. The James Webb Space Telescope, with its unprecedented precision, has recently captured shocking evidence that changes how we understand the life cycle of galaxies. Astronomers have observed an intriguing process known as quenching. This occurs when a galaxy can no longer form new stars, effectively ceasing its growth. The new data indicates that supermassive black holes are largely responsible for this quenching effect. They are not just passive inhabitants of galaxies, but active agents of destruction. As these black holes feed, they generate powerful jets of radiation and high-energy particles, which expel the galaxy's gas, the very fuel needed for new star formation, out into space, thereby starving the galaxy. One of the most fascinating parts of this discovery is how it ties into the process of star formation. Stars are born from clouds of gas that condense under gravity. However, when a supermassive black hole consumes material, it releases so much energy that it disrupts these gas clouds. James Webb's data has shown this expulsion of gas on an unprecedented scale, revealing entire regions of galaxies being stripped of star-forming material. Without gas, new stars cannot be born, and the galaxy enters a period of slow death. This has enormous implications for understanding the long-term future of galaxies. As the black hole feeds, it generates outflows that push gas away from the galaxy's center. But that's not all. These outflows can also compress gas in other regions of the galaxy, momentarily triggering bursts of star formation. However, this is a double-edged sword. While some star formation is triggered, most of the gas is expelled too quickly for new stars to form in significant numbers. The result? A galaxy that is slowly being deprived of its life-giving material. James Webb has provided us with an unprecedented view of how these feedback loops work on a cosmic scale, confirming theoretical models that have existed for decades, but were never fully proven until now. So, what does this mean for the future of galaxies, including our own Milky Way? Supermassive black holes may hold the key to the ultimate fate of galaxies. As more data comes in from the James Webb Space Telescope, astronomers are starting to piece together the life cycles of galaxies, from their vibrant, star-forming beginnings to their slow, black hole-induced deaths. Some galaxies may be doomed to die a slow death, devoid of the gas needed to sustain new life. Others may briefly reignite, only to be snuffed out once more. The universe is a delicate balance of creation and destruction, and this new evidence highlights the critical role that black holes play in this cosmic dance. Gravitational waves have become another key tool in understanding the immense forces at play around supermassive black holes. These ripples in spacetime, first predicted by Einstein, occur when massive objects, like black holes, merge. With James Webb's advanced instruments, astronomers are now better able to detect these waves and study how they influence the structure of galaxies. When two black holes collide, the energy released can impact star formation across the galaxy, further hastening its decline. These observations give us insight into how black holes not only starve their galaxies, but also trigger catastrophic events that ripple across the cosmos. Dark matter is another player in the story of galactic evolution, though its role remains shrouded in mystery. While it doesn't interact with light, scientists believe dark matter exerts a gravitational force on galaxies. As supermassive black holes devour matter and emit jets, this dark matter halo surrounding the galaxy may also be affected, altering its ability to hold gas in place. Although we don't yet fully understand how dark matter interacts with black holes, James Webb's data hints that this invisible force could play a part in the eventual starvation of galaxies, adding yet another layer to this cosmic puzzle. Black holes are notorious for their destructive winds, known as outflows. These winds, driven by the intense energy produced as a black hole feeds, can blow away huge amounts of gas from the galaxy. The gas gone, there's no material left for new stars to form, leading to the slow and inevitable death of the galaxy. The more intense the feeding, the stronger the winds, which means galaxies with particularly active black holes are at a higher risk of experiencing rapid quenching. Not all galaxies face the same fate, however. The size and mass of both the galaxy and its central black hole play a crucial role in how quickly the galaxy dies. Observations from James Webb show that larger galaxies with more massive black holes tend to experience faster quenching. These findings suggest that galaxy size and black hole activity are intricately linked, with larger black holes having a more dramatic impact on their surroundings. Understanding this relationship is key to predicting the future of galaxies and determining which ones are most likely to be affected by these deadly processes. Once a galaxy has been quenched, its fate is sealed. Without the ability to form new stars, it begins a slow process of aging. The remaining stars will continue to burn through their fuel over billions of years, but no new ones will take their place. Over time, these galaxies will become filled with older, dying stars, and the light they emit will grow dimmer. James Webb has captured images of galaxies in this very state, offering us a glimpse into the distant future of many galaxies, including perhaps our own. It's a sobering reminder that even the most vibrant cosmic regions are not immune to the passage of time. While supermassive black holes can be destructive, they also play a role as cosmic sculptors. As they feed and release energy, they shape the environment around them. In some cases, this can lead to the formation of new structures, such as intricate gas filaments or star clusters. James Webb has observed these phenomena in great detail, showcasing the dual nature of black holes. They are both creators and destroyers. Understanding this balance helps scientists appreciate the complexity of galactic evolution and the many factors that influence a galaxy's life cycle. Quasars are some of the brightest objects in the universe, and they are directly linked to supermassive black holes. These brilliant light sources are created when a black hole is feeding voraciously, producing massive amounts of energy that outshine entire galaxies. James Webb has provided new insights into how quasars signal the end stages of galactic life. As the black hole consumes more material, the quasar grows brighter, but this brightness is a sign that the galaxy is running out of gas. In essence, quasars are like cosmic beacons, signaling that a galaxy is approaching its inevitable death. Once a galaxy enters the quenching phase, can it ever recover? This is one of the big questions astronomers are trying to answer. While it's incredibly rare, there is evidence that some galaxies may briefly reignite star formation after quenching. James Webb has captured a few examples of galaxies that, after losing most of their gas, seem to have pulled in new material from neighboring galaxies or intergalactic space. However, these are usually temporary reprieves. For the vast majority of quenched galaxies, once star formation stops, it's the beginning of a long, slow decline. Supermassive black holes didn't just start impacting galaxies in the modern era, they have played a crucial role since the universe's early days. The James Webb Telescope has allowed astronomers to peer back in time, observing some of the first galaxies to form after the Big Bang. These early galaxies also contained supermassive black holes, which influenced their growth and evolution. By studying these ancient galaxies, scientists can better understand how black holes have shaped the universe over billions of years, from the very first stars to the galaxies we see today. One of the ongoing mysteries is how these gigantic black holes form in the first place. James Webb's high-resolution images have provided new clues by capturing black holes in different stages of their evolution. Scientists believe that supermassive black holes may form from the collapse of giant clouds of gas in the early universe or through the merging of smaller black holes over time. Understanding the origins of these cosmic giants is key to unraveling the larger mysteries of galaxy formation and evolution. Black holes don't just feed, they also merge. When two galaxies collide, their central black holes can come together, forming an even more massive black hole. These mergers generate enormous amounts of energy, further accelerating the quenching process in the newly formed galaxy. James Webb has observed several galaxies in the aftermath of such mergers, revealing the catastrophic impact these events have on star formation. The resulting supermassive black hole often emits powerful jets that push gas out of the galaxy, sealing its fate and ensuring that no new stars can form. Supermassive black holes are thought to live as long as the galaxies they inhabit, but do they ever die? While black holes don't age in the traditional sense, they can become dormant once they've consumed all the nearby matter. In this dormant state, the black hole no longer emits powerful radiation or jets, and the galaxy around it may experience a period of relative calm. However, if new material is introduced, the black hole can reignite and resume feeding. James Webb's observations are helping scientists understand these long, quiet periods in a black hole's life and whether they might awaken again. Galaxy collisions are some of the most spectacular events in the universe, and black holes play a major role in these cosmic smash-ups. When two galaxies collide, their black holes are often thrown into chaotic orbits before eventually merging. The energy released during this process can trigger bursts of star formation before the galaxy ultimately quells and dies. James Webb has observed several galaxies in the midst of collision, providing detailed images of the tumultuous environments created by merging black holes and the dramatic effects they have on galactic structure. The James Webb Space Telescope is offering a new window into the world of supermassive black holes. Its ability to capture high-resolution images and detect faint signals from distant galaxies has already led to several groundbreaking discoveries. By studying these distant cosmic objects, scientists are gaining new insights into how black holes grow, feed, and ultimately starve their galaxies. Webb's discoveries are helping to fill in gaps in our understanding of galactic evolution, providing a clearer picture of the life cycles of galaxies and their relationship with the black holes at their centers. The study of supermassive black holes and galactic death raises profound questions about the ultimate fate of the universe. As more galaxies are quenched, what will become of the cosmos, removing the material needed for star formation? When combined with the effects of a supermassive black hole, the impact is even more profound. James Webb has captured images of galaxies where both supernova and black holes work in tandem to deplete the gas supply. This dual suggests that supermassive black holes may contribute to the creation of these voids by accelerating the quenching process in certain regions of the universe. James Webb has begun exploring these less dense areas, revealing clues about how black holes might influence the distribution of galaxies across the cosmos. By starving galaxies and pushing out gas, black holes could help create the empty pockets of space that make up these cosmic voids, shaping the large scale disrupts the gas clouds needed to maintain a spiral structure. By contrast, galaxies with less active black holes tend to retain their spiral arms. This discovery has helped scientists understand the diverse forms that galaxies take and the role black holes play in shaping them. The rotation of a galaxy is another aspect influenced by its central black hole. As the black hole feeds and expels gas, it can alter the distribution of mass within the galaxy, affecting how it spins. James Webb's data has shown that galaxies with particularly active black holes often have slower rotational speeds. This is because the black hole's outflows push gas and stars away from the core, reducing the overall mass concentrated in the center. This slowdown can have significant not only provide a clearer view of the black holes themselves, but also allow scientists to study the galaxies hidden behind them. Gravitational lensing is helping astronomers explore parts of the universe that were previously too faint or distant to observe, opening up new avenues for understanding galactic evolution and black hole activity. The jets produced by feeding black holes don't just affect their host galaxies, they also have a profound impact on the surrounding intergalactic space. These jets, composed of high-energy particles, can travel vast distances, heating up the gas between galaxies and preventing it from cooling and condensing into new stars. James Webb has provided the clearest images yet of these jets, showing how they can extend far beyond the edges of galaxies and influence the formation of new cosmic structures. This discovery highlights the far-reaching power of black holes and their ability to shape not just their immediate surroundings, but the universe at large. Galaxies are not isolated objects. They often exist in clusters, bound together by gravity. The supermassive black holes at the centers of these galaxies can have a collective impact on the cluster as a whole. James Webb's observations have shown that in galaxy clusters, the combined outflows from multiple black holes can strip gas from entire regions, making it harder for new stars to form across the cluster. This collective quenching effect can lead to the death of not just individual galaxies, but entire clusters, marking a significant step in the overall evolution of the universe's largest structures. The cosmic microwave background, CMB, is the faint radiation left over from the Big Bang, and it provides a snapshot of the early universe. Recent observations from James Webb suggest that supermassive black holes may have had an impact on the CMB by heating up surrounding gas and altering the way it interacts with this ancient radiation. By studying these interactions, scientists hope to gain new insights into the role that black holes played in the early universe and how they may have influenced the development of galaxies billions of years ago. The James Webb Space Telescope is just beginning its mission, but it has already transformed our understanding of supermassive black holes and their role in the universe. As more data comes in, astronomers are poised to make even more groundbreaking discoveries. From studying the earliest black holes that formed after the Big Bang to observing the final stages of galactic death, James Webb will continue to push the boundaries of our knowledge. The future of black hole research looks brighter than ever, and we are on the verge of uncovering secrets that could change how we view the universe forever. The universe is connected by a vast network of filaments made of dark matter and gas, known as the cosmic web. Recent findings from James Webb suggest that supermassive black holes play a role in shaping this web by expelling gas from galaxies and redistributing it throughout space. As this gas moves along the filaments, it can either fuel new star formation or become trapped, unable to coalesce into new galaxies. This process has a direct impact on the structure and evolution of the universe, linking black hole activity to the largest scales of cosmic organization. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.